Next one, it's going to be René about secure confidential data in robot crypto library. Please.
Thank you. Hi. We have heard this question some times this day, right? Well, how are you doing the confidential data? And then I came in my mind, hey, I made some stuff last year, so maybe I can show this. So I just hacked a little bit together with the slides. One moment, there's not the slides, there are the slides. So briefly who I am. I'm a consultant. I tell customers what they should do better and how they should do better automation. I'm a robot nerd. I'm kind of a hacker and I have some security interest. The actual situation is, of course, all testers know no customer would ever use real passwords or confidential data like customer data or real databases in the test. That's fine so far, right? No other opinions? Good. But in RPA, we need this. We need real passwords and sensitive data. So we don't want to use this unencrypted in our test specifications, because maybe we want the test specification to be visible by more than one person. So maybe I have a team of designers. I have 10 or 20 people. Everybody is working on designing RPA tasks, and it's in one Git repository. And if I secure all these data so hardly, it's just leaking. And today, we have no technology problems with leaks. We have just human problems. Yeah, we have the typical security problems are humans, not techniques. So we want to prevent the humans do these leaks. And also the logs, I want to see the logs, but I don't want to have the data in the logs. And maybe they're coming an exception and reflecting some variable, and I don't want to see these in the robot framework logs. So who knows about symmetric and asymmetric crypto? Who does not know and want to know a little bit about it? Okay, I have to. Okay, so symmetric crypto is password-based, which means like AES, I encrypt with a known password, and then I hand over this password to somebody who has to decrypt my stuff, so unpack it, and then he can decrypt the stuff. The problem is, on the one hand, the transferring of the password, because if you pack the password together with the package, it's a little bit of a problem. The good thing, it's pretty fast. Like in the moment, it's hardware in the CPU, so absolutely no care about latency and some stuff, so that's very good. But the problem is always the password, and if everybody knows the password of encrypting the passwords, everybody can decrypt it, so we have, again, human leaks. So asymmetric crypto, like I'm using here in this, so we have RSA, for example, as asymmetric crypto, I'm using elliptic curve cryptography, which is this. It's pretty easy, but I don't explain it today. We have a key pair-based cryptography. That means I have two keys. Imagine I have one key, I can lock stuff, but I cannot unlock it anymore. To unlock something, I need another key. So I can encrypt data, but I'm not able to decrypt data. So if I'm one of 20 test designers or RPA designers, I can just encrypt confidential data. Then I have a cipher, so an encrypted text. And this encrypted text can just be delivered somewhere or stored in the public, don't care, because it's encrypted and nobody can decrypt it. So then we have the private key. And this is kind of a tricky thing. So the private key must be super secure, because this private key can decrypt everything what's coming encrypted from the public keys. This can decrypt, sorry, here's a typo. So this can decrypt the data here, and it must be super secret. In the crypto library, it can additionally be secured by a password. This password, of course, needs to be secured, but it's safe against brute forcing by additional things. But in generally, it's slower. So it's super secure, but it's slower, so it's only used for very critical things. So what I did with the crypto library is just the idea of these asymmetric crypto, that the RPA designers crypt confidential data, store it in the robot files, don't care about the rest, and I have some single point where I can decrypt this. So we have a few people writing this stuff. We have these public keys. We are encrypting information. This can be viewed. That can be stored in GitHub or wherever. I don't care. And then we have our test environment, and this must be secured. Also, if I have a super fancy encryption possibility somewhere on this device, messages are sent or passwords are typed in, and if you have access to this device, you're screwed anyway. So that's always, if somebody owns your computer, don't care about your use passwords, you're screwed. Yeah? So this computer must be safe. I move, then when I do my execution, I move the encrypted passwords here. Here I have my private key, I can decrypt it, and then I can run my test. And then I have my robot results. And this robot results should also be viewed. It maybe can be delivered to customers, but without these passwords. So we have to take care about two things. The one thing is the cryptography itself, and the other thing is not robot framework to screwing with our cryptography, because the logs are quite good and we get a lot of stuff locked, and we can set the log level to trace and we get more locked, and we don't want to have this stuff here. So let me just show you a little bit. It looks worse than it is. So these kind of funny strings at the top are the crypted strings, and it starts with a key, so that I know also I can do it also something like lazy description, like every time I see it, something like this, I just decrypt it. But this is now active, so what happens here, I open a browser, then here I have some keywords, I disable logging, which you can also do directly with set log level to none, and then sock level, and so on. But here it's by keyword. Then, for example, we try here to set a variable to show you that a normal secret, like this secret here at the top, this one, is visible in the reports. And then I have here this encrypted thing, and I set it also to a variable. And to see this difference, I just want to run this. And you may now decide if I can proceed, because I have 10 seconds left. Should I? No? Go, 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 okay. So, one moment. So I run this test. It's doing something, it's opening a browser, blah, blah. And then it's done, and I have somewhere my logs. Here I have my log. And what you typically would see in the normal case, like here I log the secret, and one moment, here the set variable, I see kill all humans, because this is just plain text. But directly the other thing, I see just 3 stars, because the crypto library knows there's confidential data, so it mutes it from the logs. This is the one thing. The other thing is that here the input text, input username is the user, which is an encrypted one, but you saw it typed in the administrator. And it also automatically decrypts this encrypted password. And it was also typed in, but you see here the input text does not type in anything. Here you don't see any, here the input text. You just see typing in *** into the field input username. And here you see also nothing logged. So this library takes kind of care of your encrypted data. What I also made, because I visited yesterday the Selenium extended workshop, I made a Selenium library plugin that takes care completely of these decrypted data, so that the set password or input password keyword of the Selenium library is just extended to handle these things. So when I run this test, again, somewhere, I think it was, I don't know where. There's my terminal. So the Selenium plugin, it's also, you see here now the password test 1111, which is in our test data this year. And if there's a small tool delivered with it. One moment. And then I'm finished. Python -m. Nope. Sorry. And here you can create new key pairs, you can encrypt, you can also decrypt stuff like this here. And then you see here, okay, it's test 1111. Of course, this is typically password secured and only available on the test environment. But with this small program, you can then create new key pairs and so on, and also encrypt and decrypt stuff. It's in the moment, it's kind of proof of concept. It's working, you can use it, the cryptography is safe, but what's built on top, we may work together. I'm there on Friday at the sprints, so I would be very happy if you have ideas how to improve it, how to use it, for what you could use these asymmetric crypto. So just come to the sprints and talk to me. And now I make stage free for the rest of the people. No questions.